Hello everyone, welcome to the Easy Physics again. In this lesson we are going to learn mirror equation. When we place an object in front of a mirror, we are going to get an image of the object. There is a distance of the object to the mirror, dO. There is a distance of the image to the mirror, di, and there is the focal length of the mirror. So what is the relationship between F, di, and dO? Here is the relationship. On the other hand, when you have an object, it will have an image, and the size of the image is different from the size of the object. Sometimes it's bigger, sometimes equal size, sometimes smaller. So the size of the image is changing. We call it magnification. Magnification is calculated by either hi divided by h0, which is height of the image divided by height of the object. Also, it is equal to negative of the d image divided by d object. By using these two formulas, let's calculate some examples related to mirror equation. Here is the first example. A dentist observes and checks the patient's teeth using a mirror with an 8 cm radius. In order for the hole to be seen clearly by the doctor, what is the distance between the patient's teeth and the mirror? First of all, the radius of the mirror is equal to 8 centimeters, which means the focal length is going to be equal to 4 centimeters. The doctor is using a concave mirror or a convex mirror. Let's go back to our previous lesson. Remember, the image formed by a convex mirror. When you place an object in front of a convex mirror, the image is going to be formed somewhere here, but it is always smaller than the object. Wherever is the object, the image is always smaller than the object. The image is always smaller than the object. So we cannot use a convex mirror. What can we use? There's the other choice. We can use a concave mirror. There are two cases in which we can get an enlarged image. The first case is when the object is here, when the object is between the center and the focal length, the image is inverted and bigger than the object. But this is a real image. In order to get a real image, we need a screen. So the doctor cannot use a screen. Why? Because the working area is rather small. That's why this is not a good condition for having an enlarged image which the doctor can do his work. On the other hand, also the image formed here is an inverted image. That's why it's also a disadvantage for the doctor. So the other case where we can get a bigger image, and we can get a bigger image if the object, if the object is between the focal point and the mirror, then we are going to get an enlarged image and an upright image. So for the dentist, the best way is to place the object between the focal length and the mirror. So since the focal length of the mirror was 4 centimeters, So the object distance will be smaller than 4 centimeters. Okay. That's why we cannot use a convex mirror, and the object must be less than 4 centimeters in front of a concave mirror. So the correct answer is A. Let's look at the next example. A concave mirror has a radius of curvature of 24 centimeters. Let's draw our principal axis. Here is a concave mirror. It has a focal point F, and it has a center. And this center is 24 centimeters away from the mirror. The focal length is going to be 12 centimeters. So F will be equal to 12 centimeters. If the object is placed 20 centimeters in front of the mirror, let's have our object. It is going to be somewhere here. Why? Because this is 12 centimeters and total distance from the center is 24 centimeters. So object distance, I mean this distance, is going to be 20 centimeters. Okay. Determine the properties of the image. When the object is between center and the focal point, the image is going to be inverted. It's going to be created somewhere here, bigger than the object. It will be inverted and it will be behind the center. We can check it by looking at our previous drawings. Okay, as you see, when the object is between the center and the focal point, the image is formed somewhere here behind the center. If you draw the ray diagrams, you can locate the image somewhere here. So let's go back to our question. And as you see, now the image is a real image. Why? Because the light rays from the object reflected from the mirror, they are going to intersect and they are going to form an image. That's why it's a real image. So we are going to cross these C and D. They are not correct answers. And the image is inverted. As you see, it is not upright. So the correct answer is B, and it is enlarged also. As you see, it is enlarged. I mean, the image is bigger than the object. So the correct answer is B. Let's go to the next example. The mirror shown below has a radius of curvature of 3 meters. The radius of the curvature of the mirror is 3 meters. R is equal to 3 meters. This means that focal length is going to be equal to 1.5 meter. An object is placed in front of the mirror and an image with a magnification of 1.5 is formed. Magnification is going to be equal to 1.5. What does 1.5 magnification means? First of all, the absolute value of the magnification is bigger than 1. It means image size is bigger than the object size. Second, since this is a positive value, it means that the image is an upright image. So, what can you deduce about the nature and location of the image? Draw a ray diagram to show the image formed by the mirror. Okay, so let's continue with our mirror equation. We know that M is equal to negative the image divided by the object, and the magnification is equal to 1.5. So this means that the image is going to be equal to negative 1.5 the object. Let's write our mirror equation. One over f is equal to 1 over the object plus 1 over the image, and 1 over f is 1.5 equals 1 over the object and plus 1 over the image distance is equal to negative 1.5 the object. Okay, now to make a simple mathematics, let's multiply everywhere with 1.5. If you multiply everywhere with 1.5, I mean multiply this one with 1.5 and multiply this one and that one everywhere, if you multiply with 1.5, you are going to get 1 here, because if you multiply this one with 1.5, it will be 1.5 divided by 1.5, so you are going to get 1. Then if you multiply this one with 1.5, it will be 1.5 divided by the object, and here we have a minus. If you multiply this one also with 1.5, we are going to get 1 over the object. So if we make this subtraction, we are going to get 0.5 divided by the object. 1 is equal to 0.5 divided by the object. It means that the object is going to be equal to 0.5 meters. Okay, so but we know that the image is equal to 1.5, negative 1.5 the object, so negative 1.5 times the object is 0.5, so totally it is going to be equal to 3 over 4 meter, but negative 3 over 4 meter. What does this mean? It means that the image distance is negative, means that the image is behind the mirror. So let's use the ray diagram and draw a ray diagram to show the image formed by the mirror. Let me draw my mirror here, and the focal length was 1.5, and this is the focal length f. The focal point is here f, and center is somewhere here, but we know that focal length is equal to 1.5, and we found that the object is 0.5 meter away from the mirror. The object is going to be somewhere here, and we found that the image distance was negative 3 over 4. It is going to be equal to negative 0.75 meters. Since it is negative, the image is going to be formed behind the mirror. It's going to be formed somewhere here. So can we draw the ray diagrams to locate the image somewhere here? Let's do it. So let's draw a parallel ray to the mirror. A parallel ray to the principal axis to the mirror will reflect from the focal point. Another light ray from the object reflect from the pole of the mirror with the same angle. As you see, these two reflected rays are diverging. They appear to come some point behind the mirror somewhere here. So this means that the object is located, the image is located somewhere here. That's it. Thank you for listening.